And she looked down her nose at me and sneered, "What lady would take mathematics instead of Latin?"
That lady's telescope is in Florida right now, bolted to a rocket, built to fact-check a Nobel Prize. Her name was Nancy Grace Roman, NASA's first Chief of Astronomy. The woman who talked the world into putting telescopes in space. And this is the story of the question she wasn't supposed to ask, and the answer her telescope might overturn. A Nobel Prize with homework is a big claim. We're getting there. But to understand why this telescope of all telescopes gets to grade it, you need to meet the woman it's named after. Because the prize only exists thanks to the fight she picked. Nancy Grace. Roman fell in love with the sky as a kid. At 11, she organized her friends into an astronomy club. And she never looked back. The problem was that everybody kept asking her to. That algebra comment wasn't a one-off. She remembered that, at Swarthmore College, the Dean of Women interviewed every incoming girl. And if she couldn't talk you out of majoring in science, she wanted nothing more to do with you for 4 years. In her junior year, the head of the physics department gave her his assessment.
"You know, I usually try to talk women out of going into physics, but I think maybe you might make it."
That was the encouraging version. She made it anyway. Doctorate in astronomy from the University of Chicago in 1949. Though her thesis professor once went 6 months without speaking to her, even when she said hello in the hall. Then a decade of watching doors close. She left academia because she didn't think she could get tenure as a research astronomer. By her count, one other woman in the country had it. So in 1959, when a brand new agency called NASA asked her to build its astronomy program from scratch, she jumped. Nancy Grace Roman became NASA's first Chief of Astronomy, and the first woman in an executive job at the agency. And here's how that worked. The government hired her as a fresh PhD. 6 years of research and an international reputation, none of it counted. Civil service wouldn't recognize her university salary as professional experience because it had been too low. She'd been underpaid, so the government counted her as inexperienced. In that era, a woman could struggle to get observing time at the world's great telescopes. Her answer was to build telescopes nobody on Earth could book. The big idea she championed sounds obvious now, and sounded expensive then. Put a large telescope above the atmosphere, where stars don't twinkle, and the sky is never cloudy. Plenty of astronomers considered it a fantasy that would eat their funding. So Roman did the unglamorous part of visionary work. For years she pulled astronomers and engineers into the same rooms, turned "wouldn't it be nice" into hard engineering requirements, and wrote the justifications that went to Congress. That slow, stubborn campaign became the Hubble Space Telescope. It's why people at NASA still call her the mother of Hubble. Hubble launched in 1990, and Roman got to watch. It spent 3 decades rewriting astronomy. She kept working and kept mentoring into her 90s. On Christmas Day, 2018, Nancy Grace Roman died at 93. 2 years later, NASA took its next flagship observatory, the one built to attack the biggest open question in physics, and put her name on it. Which brings us to the Nobel Prize. To get why it needs fact-checking, we go back to 1998. To 2 rival teams of astronomers racing to answer the same question: how fast is the universe slowing down? Because that's what both teams expected to measure. The universe has been expanding since the Big Bang. Gravity pulls everything toward everything else. So the expansion has to be slowing. The race was just about how much. Their tool was a particular breed of exploding star, the type Ia supernova. When one detonates, it comes out close to the same brightness every time, and the leftover differences follow a rule astronomers can correct for. The brighter ones fade more slowly. Correct for the fade, and you've got a standard candle. The universe's own calibrated light bulb. Find one that looks faint, and you know it isn't dim. It's far. Faintness becomes a tape measure. So both teams hunted distant supernovae, measured their light, and got the same wrong-looking answer. The distant ones came in about 20% fainter than they should have been. Fainter means farther, 10 to 15% farther than a slowing universe could have carried them. Both teams checked. Both teams rechecked. Each half hoped the other would find the bug. There was no bug. The expansion of the universe is not slowing down, it's speeding up. Something is pushing. Nobody knows what. We call it dark energy, which is science for the biggest thing in the universe, to be determined. And it is the biggest thing, about 68% of everything there is. In 2011, the discovery won the Nobel Prize in physics. Here's the part that ties this whole story together. Those supernovae didn't explode last Tuesday. Their light spent billions of years getting here. For the farthest of them, more than half the age of the universe. So when those teams measured dark energy, they weren't measuring the present. They were reading history. The universe's expansion, recorded in ancient light. Every deep telescope is a time machine. And here's the number that should raise an eyebrow. The distant supernovae that whole revolution rested on, between both teams, numbered 56, plus a few dozen nearby ones to calibrate the ruler against. 56 exploding stars rewrote the fate of the universe. For almost 30 years, that answer held. Dark energy went into the textbooks as a constant. The same push, everywhere, forever. Then the tape measures started getting audited. In 2025, a team of astronomers in South Korea published a challenge. What if type I supernovae can't be standardized after all? Their claim was that a supernova's brightness depends on the age of the star that produced it, and no fade rate correction catches that. Since the early universe only had young stars, the distant supernova might look faint for a boring reason instead of a cosmic one. Take their correction at face value, and the acceleration shrinks. Maybe, they argued, it was never there. The pushback came about 6 months later, with 2 of the Nobel winners on the author list. 1, the challenge left out a standard correction that already tracks a supernova's environment, so adding an age effect on top risks counting the same bias twice. 2, it treated the age of a supernova's home galaxy as the age of the star that exploded, and a galaxy holds stars of every age. Run the numbers with the standard corrections, the rebuttal finds, and the age bias shrinks to nothing. The Korean team fired back this spring. They are not conceding. But as of right now, the scoreboard reads, acceleration, intact. Case closed? Not quite. Because at the same time, a different experiment entirely, DESE, a spectrograph in Arizona that has mapped tens of millions of galaxies, keeps finding hints that dark energy might not be constant after all, that it might be weakening, evolving. Depending on which datasets you combine, the signal sits somewhere between about 3 and 4 sigma. That's below the 5 sigma bar physics demands before it pops champagne, but far too big to wave away. So here's the honest scorecard right now. The universe is still accelerating. The 1998 result has survived every audit thrown at it so far. But 30 years in, we still don't fully understand our own rulers. And the thing we're measuring with them is the fate of the universe. Pretty sure is not where you want to leave that. Enter Roman, the telescope. Its mirror is the same size as Hubble's, but where Hubble sees the sky through a keyhole, Roman sees it through a bay window. A field of view at least 100 times larger. One Roman image carries the detail of 100 Hubble pictures. Point that at the supernova problem and the numbers get silly. Remember the 56 distant supernova the Nobel stood on? Roman is designed to find tens of thousands of them, reaching back around 11 billion years. deep into the universe's childhood. Not a handful of points on a curve, the whole curve. If dark energy has been changing over cosmic time, Roman is built to catch it in the act. And if our rulers are biased, tens of thousands of supernovae through one instrument is how you find out. The last chapter of this story is almost too on the nose. This telescope nearly didn't exist. 4 times, across 4 separate budget years, the federal budget proposal put the mission on the chopping block. 4 times, Congress put it back, but by the 4th round, the telescope being defended was already finished, ahead of schedule, and under budget. It refused to hand anyone a reason, so here we are. This summer at Kennedy Space Center, engineers loaded the finished observatory with 290 gallons of hydrazine. And you don't fuel a spacecraft, you don't intend to fly. It rides a Falcon Heavy out of Launch Complex 39A, the pad that launched Apollo 11, and NASA says it's running about 9 months ahead of schedule, bound for a gravitational parking spot, 1 million miles from Earth. By the time you're watching this, it may already be on its way. And there's a seam running through all of this. In high school, a teenager asked for more math and was told her question wasn't worth asking. She spent the next 7 decades asking anyway, and building the machines that let the rest of us ask bigger questions. She died without ever hearing her name attached to this telescope. And now the telescope that carries her name is about to spend years asking the most Nancy Grace Roman question there is. That answer everybody's sure about. Did we actually check?
People generally aren't terribly interested in what gets things started. And so I'm not sure they're going to have much of an idea of my role.
What lady would take mathematics instead of Latin? That one. And she was wrong. About one thing. We know exactly what she started. It's about to leave the planet with her name on it. If you want to be here when Roman's first answers come back, subscribe. New stories of ancient light every 2 weeks. Next time, another question. Somebody wasn't supposed to ask, and the machine that answered it. See you then.